So have you ever been struggling with that difficult part, with complex geometry and inserts that just won't infuse, leaving you with dry spots or voids? Or what would it do to your business if you could increase the speed of your process to reduce the cycle time? Or make a part which weighs much less? And on top of that, with a carbon footprint that is lower than your products today. Imagine having that discussion with your customer and with confidence being able to address all these challenges. Let's see. If technology is with me. Okay. I don't know what this. Sorry about that. Sorry. What? So, hello, good afternoon. My name is Robert LUTTU. I'm from EXXONMOBIL. I'm together with Frank Henning from Fraunhofer ICT. We'll tell you how Proxima thermoset polyolefin resins will help you redefine how you think about thermosets. So, we're going to start by the infusion part. So we set up side by side. 1 meter length, 4 plies of unidirectional glass fiber, 1182 GSM. And we start infusing and see how our Proxima resins compares to an epoxy resin. If you can run the video, please. So on the left-hand side, you see Proxima infusing quickly, and the epoxy is running to the right-hand side. So we offer our Proxima resins in a wide range of viscosities, from these very low viscosities up to high ones required for techniques like pultrusion and filament winding. So now, after half a minute, the Proxima resin has reached the end and now is filling the part. So after 53 seconds, the Proxima resin has filled that part. So for sake of time, we are increasing the speed. And while the epoxy resin is filling the mold, I can tell you more about our resins. So it's compatible with most of the carbon fiber and glass fiber materials, as well as core materials. It has a lower density than epoxy, approximately 10% lower. So enables weight savings. And it has a hydrophobic nature, so chemical resistance is very good. So you can, with a low water ingress, you will have a low corrosion resistance and good resistance to alkaline or acidic environments. And we're closing to the finishing line. So 18 minutes for the epoxy to fill the mold. So for this particular resin, it was 18 times faster. So moving on to curing after we fill the mold. So we can run the video. So the Proxima resin is a two-part system with where you add 2% of catalyst. And as you can see, it has really high reactivity, so enabling a snap cure of your production. And we also have we offer a wide range of catalyst systems that also offer latent cure or curing at higher temperature as required by your conversion techniques. So these catalysts are sprung from Professor Grubb's research in Caltech that awarded him the Nobel Prize in Chemistry 2005. So that's where we're bringing to the market now. So we can accomplish this without trading any performance. So laminates made with Proxima has higher toughness, about 5 times, as a laminate made of epoxy. So you get that with a lower weight product. So what we can demonstrate this quite easily by dropping a 7 kilo weight onto these laminates from 40 centimeters height. And just to show what is the damage done to those laminates.
Ready? Yep.
So quite an easy way to demonstrate. And you can visually see the difference in impact. On the left-hand side, the damage down and the lamination of the epoxy laminate. And the right-hand side, the much lesser damage to the Proxima laminate. And coming to the carbon footprint, all this is done with a material that has a significantly lower carbon footprint than other resins used in the industry. So we had Sphera make an assessment of our products and landed on a number of 2.8 kilos per liter of Proxima resin. And as you can see, it's significantly lower than other types of materials. So all in all, with that, we have a product which helps you produce faster, lower weight, with better performance, and a lower carbon footprint. If you want to learn more about the sustainability aspects, come back here tomorrow at the same time, where my colleague Christina will tell you more about how to innovate with sustainability in mind. So by this, I hand it over to my colleague Frank, who will tell you more how we can work together to help you improve your business.
Which is moving forward?
That is the one.
That is moving.
Yeah.
Okay. So, thank you, Robert. How can Fraunhofer ICT help to produce these composite parts? Fraunhofer is intensively working on the development of processes, optimization of processes, has available different processes as medium to large scale in operation for part development, part design, part optimization, and not only in Germany, but also in our facilities in Canada and Korea. So our focus is on modifying formulations. You've seen it's a large variety of viscosities that we can achieve and adjust. And what we have is we want to have a rapid mold fill, but we have to make sure that there's no gelling during the mold filling, and then we want to have a kind of a snap cure. So the one thing is adjustment of the material itself. The other thing is optimizing the process parameters to that degree that you have a robust process and that you have the shortest possible cycle time. So it's about material formulation, but it's also about the technologies that you see here in the upper right corner, wet pressing, wet compression molding, RTM, pre-preg pultrusion that we are looking at, and we can provide here help together with you and EXXONMOBIL. We are working with on industrial solution utilizing this new resin system. I just want to point out that there are multiple opportunities to collaborate. So we have a center in Canada that provides the technologies as well. for our partners in North America, as well as in Asia. We have our partners at Ulsan University at UNIST, where we work in this composite center on our pultrusion, as well as on compression molding, wet compression molding in RTM. And in order to optimize these processes, just as a side note, Fraunhofer is intensively working on artificial intelligence supported material development and also manufacturing in order to faster optimize and survey the processes in order to get to a robust manufacturing. And that we are doing together with our colleagues from Ostrava and the Czech Republic. The Fraunhofer innovation platform in Canada did some work on the Proxima system. That was focused on high pressure RTM. In fact, as you see, there's a little contradiction already because high pressure is not required anymore because we have such a low viscosity. It's more or less the accurate mixing and dosing that these high pressure systems provide. So we've selected this as a technology to start with because it has excellent part properties with a high fiber volume content. We reach high surface qualities, we reach high productivity, and it's a robust processing. So it's very interesting, especially when you talk about automotive parts, to scale up this material system. We worked with different reinforcement, as you can see here, just to name a few, to show some examples with different parameter and also different weaves and non-crimp fabrics, but also with carbon to see how this material behaves and corresponds with the existing resin, with existing sizing systems. So for most of the class, it's easy to process and to adjust, but obviously we have to undergo an optimization process for each of these processes. As my colleague said here from EXXONMOBIL, we need basically to tailor-make the formulation for each process. As you saw, we also did a leaf spring there, so we can go through many layers in a very fast time, taking advantage of a short cycle time and the high energy uptake of that material. We distinguish usually two sectors. One is structural lightweighting, where we talk about continuous fibers, and the other one is functional lightweight design, where we talk about discontinuous fiber reinforcements. We distinguish the thermoplastic and the thermoset side. And the area of collaboration with EXXONMOBIL will be the thermoset side, where we talk about the resin infusion system. And those who know us and know the research also on thermoplastic in situ polymerization, we are very familiar with these low viscous materials to deal with, to seal molds, to process this low viscosity materials in a robust manner. We developed, together with our colleagues from KIT, the Karlsruhe Institute of Technology, the so-called M⁻³ approach, which is basically developing products along the same methodology like you evaluate later on with the life cycle assessment. So we consider basically all the three areas. The ecological point of view, obviously societal, which is for composites very often also emotion. To buy these type of products, and then obviously the economic side, where we consider different markets, different sizes, different distances to infuse. It's a complete different story if you talk about an automotive part that size, or if you talk about a wing structure or rotor plate. So we have to tailor-make not only the process parameters, but also the material parameters to make that work. And obviously that's our sector where we feel most home, at least me as an engineer. Right? So talking about the way of designing parts adequately, tailor-make the materials to work with that design, especially when you have complex shapes, trapeability, so it's not just the resin, it's also the fiber architecture, and then obviously the manufacturing. And our specialty is to also look in manufacturability a lot. I have an example that I brought with me. But I guess the message here behind that line is we have to bundle competences. And in our network, we have very capable partners to do so. I just want to quickly introduce the house of competence that you can expect when you work with us together to find an application for this resin, which are the methods. So we are very well established in the virtual design of composites. So process simulation is one of our strongest capabilities. Looking into curing while you're infusing. So you see how the viscosity is changing, and you know that's not an easy task to determine the material properties, to feed the simulation tools with the right material maps. We do structural simulation and then obviously the optimization of that from a methodological point of view. And then we are looking into material development, whereas the chemistry part is not on our side. On our side is the modification of the chemistry, filling, reinforcing, and functionalization. So it could be flame retardancy, which is a topic that we address as well. So it's more or less the physics, not the chemistry. The chemistry is done by EXXONMOBIL in our partnership, and then we basically determine the material data card that we need to feed our methods to tailor-make these simulations for this material so that we can optimize your products to get to a cost-efficient and fastly manufactured part in the end. Then the manufacturing, which is providing a large range from lab size to industrial size up to 3,600 ton press, where we can do complete automotive floors and roofs and side panels at the ICT at different sizes. And then obviously we help our partners to do technology transfer also through our facilities overseas and through our spin-off company Simutens, who provides these methodologies as a service to the industry in order to optimize the processes. Let me show you one example. We did that together with Audi and Volkswagen on a public funded project. That's why, and it is quite some years ago on a different resin system, where the goal was also to be fast, but unfortunately at that time we haven't been that fast, but we had developed the methodology we can apply now here for our partners at EXXONMOBIL, where we can take advantage of this virtual process chain that we developed, where we look in the consideration of the manufacturing effects and their influence on the structural behavior. So everything that the process does to the material, to the reinforcement as well as the resin, is translated and fed into the structural simulation later on. We can verify the manufacturability of this specific geometry that is suitable for your application. We can do iterative optimizations on several simulation steps and come this way to a virtual design and process optimization, and therefore can accelerate the design loop significantly by utilizing these virtual design tools and not relying on too many manual tests. So that's the example. It's a vehicle floor structure that was made here in the carbon RTM process. This has a woven fabric, but it has also unidirectional tape reinforcement. It has a sandwich core structure in these areas. So it's a pretty complicated part when it comes to different wall thicknesses, flow distances, and in order to apply our software or our algorithms to understand where to inject, what speed to inject in order not to move the fibers, depending on the viscosity of the resin, to get basically the fastest possible infusion without any dry spots, and then to be close to the gel point and snap cure with the chemistry that you've seen in the presentation before. And then basically after we have the manufacturing secured, then that's just an experiment to verify our codes. And what you see here on the left-hand side is we can handle very reactive resins. Usually when you do a plate-to-plate rheology to get the data, it's very tricky because the material gels already or cures already before you even start the test. Now we do online blending and online mixture, so we have developed the devices where we can mix while injecting between the rotary discs and measure from the first seconds the cure state, and can build that in our simulation. And then finally, obviously, do the simulation, the curing simulation, thermomechanical simulation, which then leads to warpage prediction and helps to optimize the part from this respect. So what are the goals of our collaboration? We want to join forces to catalyze innovation. That's our purpose, to present that to you. We have a very interesting new resin that has a couple of advantages. We have the processes at hand. We have the material data cards we can develop. That's what we are planning to do as a next step together. And then we are ready to team up with our clients and especially you to find out the applications and to optimize the part and see where we can go from a cost point of view, from a cycle time point of view, and from a performance point of view. So it's all about physics-based process understanding combined with form filling and mold filling simulation with process and product design optimization. That's what I think Fraunhofer can bring to the table here together with our partners. And the focus, sustainability, flexibility, and also more and more applying AI-supported part development, but also process development. So with this, I want to conclude my presentation, and I want to thank you for your attention. My colleague Robert from EXXONMOBIL and myself are ready to answer questions if there are any. And after the talk, we will be standing at the side of that booth here if there are any further questions that we are happy to discuss with you. So thank you very much for your attention.